Hi there guys, I just thought I'd make a quick video to show you how to do an extension of your mains water supply to an outbuilding, and we are actually converting our outbuilding into a gym slash storage area, and we want to put a shower and a boiler in there and stuff, so I thought I'd make a quick video on how you can do that. So here's the original lead pipe that goes into our property, and you can see basically what I've done is added a Philmac UTC, which is a universal transition coupling device, which connects to kind of lead pipe, copper pipe, any kind of pipe at all. It's got some grips on the inside of it and a quite a thick O-ring, and they have different sizings, size ranges for those coupling units. I've gone for a 25mm MDPE, which is the blue pipe, to a 21 to 27mm range, because our lead pipe is 24mm, which is a bit of a weird size, so they come in different ranges, and this is the one that fitted ours. I'll have links at the bottom for all the products that I use in fitting all this together, so you can just check out what all the bits are that you can use if you want to do the same setup for me as that I've done. And basically what I've done is I've put this coupling unit onto the lead pipe, then onto a small bit of MDPE pipe, and then onto a T-junction, and this goes to our house on a 25mm MDPE blue pipe, which you can get from Screwfix or somewhere, and then I've basically connected up to our house, and our house originally had a 20mm blue pipe, so I basically used a reducer coupling unit, so I've gone from 25mm to 20mm. With all the connections that I'm showing you, need to have the appropriate spacer that slots into the blue pipe so that you can compress up against it when you're screwing and fitting it tightly. So this is a 25mm spacer. They're really cheap. I think they're about 30p. And then on the 20mm that you can see that I've just pointed at, you need a 20mm spacer. One other thing I should quickly mention is that when you're fitting these compression joints together, make sure that these pipes are in line with the connections, because what's inside here is a grip, and then there's an O-ring here, but the actual thing that's sealing the pipe onto this unit is actually just the O-ring, because there is a space in the grip, so it slowly grips down onto the pipe, but there's usually like a space like that where water can flow out of, and we learnt pretty quickly that the pipes need to be going in a straight line along this T, without too much stress trying to kind of hold it away from its line, otherwise it will be skewed inside the joints. So we had a bit of leakage at the start, so I'm standing in a bit of mud, and this one especially, when it's going around the corner, we had to take it around the inside of the corner, just so that it was more in line with this connection here. So that's how it's going into the house, and originally it was just a lead pipe that was connected to the 20mm blue pipe there with another push fit kind of coupling unit. But what I'm doing now is I'm extending it out to our outhouse on a T-junction. And for our borough council, you're required to use, in our borough, we're required to use at least 25mm blue pipe to put mains water in now. So I've gone for a 25mm, and it's extending about 30 metres all the way up to the outbuilding. So I ended up getting 50 metres of blue pipe, and it's good to get a little bit extra because you need to cut extra bits, like for example this extra bit I needed. So if I got 25 metres, it's pretty close to 25 metres, so if I got 25 it would have been too short. Anyway, I'll show you a little bit more about the hole that's been dug. This has now all been approved by the inspector from that's come around from Sutton and East Surrey Water. So they come out for free. You just need to dig the hole show where you're going to connect it, don't actually connect it yet, and then dig the trench all the way to the place that it's going to be fitted to. And then at the end, which I'll show you, you need to put a stop cock, which is a tap, and a drain cock valve, which is connected to copper pipe. That's just a solution that I come up with, but I actually, you probably see, there's probably a video above this that shows a normal installation of water, mains water supply, and I just use the same design as the guy above. Yeah, I'll just show you a little bit more about the trench. So basically the trench runs all the way down through this alleyway, and it's got to be at least 750 mil below ground. We're actually having a patio here, so I've done this. The patio is going to be an extra 150 mil on top of the soil here, so in some parts it's only 600 mil deep, and the inspector said it was completely fine, so that's fine. And then we're going to have another gas pipe above for the boiler. But I've filled all of this in now because at the moment it's quite close to foundation, so we wanted to make sure it was filled a little bit in case there was quite a lot of rain that came down, just to make sure the foundations were fine. So basically it's just digging all the way, and this was actually here just to make sure the inspector could see the depth of the pipe, even though we'd filled it in. So what you can do is use a bit of drain pipe, and if you're worried about the area, just if you're worried that this is all going to fall in and it's in a dangerous position, you can put the drain pipe in different positions, and then they can look down the drain pipe and put a measuring tape in and cut it off to the same level as the floor and check what the depth is. And you can also see that the little extra bits in there that we've put in, which is a bit of sand and stuff. So yeah, so basically digging under all of these little bits and bobs. Make sure if you've got trees near to the trench that you're digging, make sure you don't damage big roots, because the tree can be unstabilised. So what we've basically done is the small roots we've completely smashed out, and then the big roots like this one we've just hollowed out underneath of. So you can see there, and then the same with this one. And if you're going over obstructions rather than going underneath, you actually need to put a drain, you need to put protection around the pipe, because as the soil sinks and it becomes compressed, you can actually put pressure on the pipe. So in a regulation sheet that that we got from Sutton East Surrey Water, it said make sure you've got like a drain guttering pipe or something like that if you have an obstruction below the pipe. But we've chosen to go under all the obstructions to make sure that we're at the right level, which is 750 mil or more, 750 mil to 1,350, and you can't go deeper for some reason. Part of the regulations. So basically, you're going further up here. This is all going to be a patioed area, and then we're going to have gas pipe running 350 mil above below the ground. Now what you can see we've got is some sand. The sand is just there to make sure that there's no like sharp stones kind of getting in contact with the blue pipe, because once the soil compresses and stuff, the blue pipe, if you scratch the blue pipe, it needs to maintain its pressure. So it's got a certain wall thickness to maintain that pressure, and if you start scratching it, it's going to damage the pipe and not be good, and you might get a leak underground. So we put a bit of soil, we put some just normal building sand, but you can use sharp sand. Building sand is a lot softer and rounder granules, so it's much nicer to keep the blue pipe protected. But what I've done, you can see we've got sand, you can see the blue pipe poking through there. Then you put a little bit above, a little bit below. It doesn't have to be all the width of the trench. This was all actually dug out with a mini digger. I'll show you a quick video now of me digging out. I got completely sunburnt that day, so make sure you wear sun cream if it's a hot day. And I just used, if you're hiring a mini digger or asking someone to dig with a mini digger, then use the thinnest pipe possible, because it means that you don't have to backfill as much soil, the thinnest bucket as possible, sorry. So we used a 150mm bucket, which is about that big, and then it scoops out a small amount of soil, and then you don't have to fill as much dirt. This would have been twice the amount of dirt otherwise. Now we're going further up the garden, and it's not a complete straight line because we're avoiding some obstructions. So we've got a soakaway here on the left, and I actually had another soakaway here that's underground, just on the other side. So we're just avoiding all the obstructions. That was a concrete lid, so I didn't want to dig through that. It meant hiring a Kango and stuff like that, pneumatic drill. And in this section, we've actually got raft foundations in our garage. So it basically means that it's a raft is basically just a flat piece of concrete with reinforcement in it. And you don't have to put the pipe in this way, but this is the way that we chose to because it's the cheapest solution. And basically we bored a hole through the foundations, and I've got this guttering as mechanical protection because we're going to put a step over the top of this area after it's all been fitted and built up. So usually wherever there's any kind of heavy weights on top, or going to be any kind of heavy weights on top, you should put some mechanical protection. So what I've done is just extended that out a little bit, and when I was digging underneath the foundations here, I actually used a slightly wider bucket on the mini digger because I knew that I was going to be standing inside of it. It's pretty difficult to stand inside a 150mm width hole, so I ended up using a 300mm bucket just for that section. Yeah, so basically the regulations say in our area that if you are, this is the garage that we're converting into a gym, and there is all the MDPE pipe on the floor, and there is the hole that is bored through the ground. That took a long time because it's just complete concrete with reinforced bar inside of it. I can show you some of the reinforcement that was inside. Here we go. So basically this is a little bit of it. I ended up drilling with a hammer drill in positions all the way around the actual bore that I was using, because I couldn't. It would take me the whole day because there was no way of getting rid of the dust. But you can see the reinforcement bar that's inside there. Trying to bore a hole through that is pretty damn hard, but we managed to do it. It took about 3 hours instead of the whole day. So what you need to do, the regulations around in our area, and I've checked on various council websites because I couldn't find the regulations for our area for a while, so I just found some on Google, and it's all the same. Basically, if you're installing a water pipe into a building, if it's going to be 750mm or more away from the external wall inside the property, then you don't need to insulate this tube coming inside. But because we're going to have some cabinets, here, and we want them to be within the cabinets. So our cabinets are going to be something like just finishing here. We want them to be within the cabinet. We've had to lag the inside of the pipe, and you can just use normal lagging that you get for copper pipes. So any hardware store, I can show you a link. I've got a link in the bottom that will show you the lagging that I used. It's just 22mm lagging that you use on copper pipe, and it fits nicely around the 25mm pipe here. And that should just go on all of the area that is 750mm. Anything that is less than 750mm away from the external wall, and is not 750 mil deep in the ground, it needs to be insulated. So this pipe is actually just insulated all the way down to its bend at the bottom, and then once it gets out from the bend and is 750 mil or more below the ground, it's no longer insulated. So you can see the little bend that I've got going on underneath. I'll show you. So you see there's like an elbow under the ground that goes up into the raft. It's only insulated until the bottom of that elbow, because it doesn't need to be insulated anymore. And another point is that both ends of the guttering need to be sealed to stop vermin or mice or anything from getting inside, because they can bite away at the water, and that's going to ruin your supply of water. And it's going to be pretty difficult to dig all that back out again, so you want to make sure they can't get in if they do burrow underground and get in, especially moles or something like that. So basically what I've got is, on both ends, in case they enter from the house side or the underground side, is this. It's called a universal waste adapter for 110mm pipes. So that adapter basically has a little hole here, and you can cut out any size of pipe, and then that will fit directly onto there. I've got a bit of excess lagging here that I don't need, so I'm going to cut that off later. But that will fit directly onto there and seal around it nicely. And the final part is the stopcock and the drain-off valve. So basically, we've just tested this to see if it's tight. So it might be leaking with a bit of water. Basically, what you need to do, we've got some excess here because we don't know exactly where we want to put the MDPE pipe. So we've just got it laying on the floor, but I'm going to cut it exactly to length and pin it up against the wall. Just at this end, it's just going to basically be pinned up against the wall like this. So facing the other way, the way that's opposite to what I'm showing you, it's going to be pinned up against the wall. Just going to put some wooden blocks behind it and then clip it into position. So basically, I'll show you, it's going to end up looking like this against the wall, and so it will change direction to the boiler. The first thing that's going to go to is the boiler. So it can go left or right, and an elbow can go left or right, so I've just put an elbow on it so it doesn't go any further up into the cabinet. And then basically the stopcock has a compression fitting and a spacer inside, and that goes directly onto the MDPE pipe, the blue pipe. And now I've got a 22mm copper pipe on here that I've cut, and then an elbow, then onto 22mm again pipe, and I've put a T-junction on, and then I've just put a drain-off valve, a 22mm drain-off valve. So this is an equal 22 mil T-junction, and this is a 22mm drain-off valve that fits on here with a compression fitting. All of these have got olives inside them, and an olive is just basically, it's just a piece of copper that can be compressed, and when you turn the nuts on the brass fittings, they compress the copper up against the copper tube or the MDPE pipe, and they grip into it. So I mean, once you've tightened it up fully, you can only really use the copper once, the olives once on the MDPE pipe, and then you have to get a new one if you wanted to refit it. So I've got a second olive that I'm going to put on here once I not a second one, sorry. I'm going to take this one off, and it's not going to be usable again with a little olive, and then I'm going to put a new one on once I've cut this all to length. So So I'll just show you the bore that I use to drill through the ground, because that's quite important. This might be a unique case, but quite a lot of outbuildings have rafts to sit on because they're quite easy to build, and they're lightweight structures, so they don't need to have deep foundations. So this is it's probably going to be quite common. So what I did is got a bore that has diamond bits inside these bits here, and this is usually just used to drill out holes into walls for a lot lower down for toilets and guttering and stuff like that. But I've basically used it to bore down into the ground, and it's about 115, 120 millimeters diameter, which is perfect for fitting guttering into place. You don't have to use guttering, but it's just a lot easier to. I called them up quite a lot about this, the water company, and I said, can we use something smaller because we don't want to damage our foundations? And they said, well, ideally you can use 100 millimeter guttering. You don't have to, but when you want to put the lagging on and you want to push it through, this stuff is quite stiff. So it's actually quite difficult to push through if you've got anything thinner than that. So we bored it out with this, and I ended up actually drilling deep holes into the to get all the way through. Ended up drilling really deep holes into the at different points with a hammer drill. I drilled there, all the way around, because it actually needed some space for the dust to travel down, and there was less material to remove, and the dust was actually travelling down rather than, because on those bores there's nothing like a normal drill to pull out the dust. So you either have to drill, hoover it out, and you don't get anywhere very quickly, or you can bore holes all the way around the diameter of where you're going to try and drill holes. All the way around the diameter of where you're trying to bore, and all the dust will just go down, and you'll get to the hardcore pretty quickly. So that's pretty much it. Yeah, just to show you that it's all working. We've now got all mains pressure on here, which in our area is actually about 7 bar. And so I'll just turn the stopcock off. There we go. So that turns the water on. We've got mains pressure water in there. Pretty exciting. Anyway, I'll create a few more videos on a few bits and bobs that we found difficult along the way, just to help you guys out on how to convert your outbuilding into whatever you want to. We're turning ours into kind of a gym with a little bar and storage, so let's get on with it. Thanks for watching, guys.